The diagram shows some force acting on a toy car. So the force backward in direction is 1 Newton, while the force forward in direction is 3 Newton. Usually we can say the force forward in directions by the engine force, while the force backward in direction by the air resistance or the land resistance. So which row of the table describe the motion of toy car? So the force forward in direction, that is a 3 Newton, minus the force backward in direction, that is 1 Newton. So the resultant force will be 2 Newton forward in direction. So with accelerations, while because the forward force will increase the speed of the car, so this will be acceleration. So A is our correct answer here. Question number 2, the diagram shows the positive charged rod near a small piece of paper. So if there is a positive charge rod near the small piece of paper is given there. So this question is related to the charge inductions. So for example, if you're bringing the positive charge rod near the piece of the paper, so the positive charge will attract the negative charges. So on the surface of piece of paper, so in this way, that will generate a negative charge of the surface of piece of paper, which is near to the positive charge rod. So we can see that which diagrams show the correct distribution of the charges and the negative charges on a piece of the paper. You can see that, for example, the option A is wrong. Why? Because positive charge will attract negative charge. It will repel the positive charge. So that's why there's a wrong distribution in A option. While in option B, there is the positive charge will attract the negative charge. But you can see the surface of paper is not regular, so the charge will not regularly arrange. So that's why the arrangement of the charge here regularly in an irregular surface of the paper, that's wrong here. So what about the point C? That's also wrong because these are same charges. And the point D is correct here. Why? Because the positive charge rod is attracting the negative charge, which is the surface of the piece of paper, which is closer to the positively charged rod. So what is the concept behind that? The electrostatic induction in the paper will generate a negative charge. So on the piece of the paper, which is near to the positively charged the rod here. So this is our electrostatic induction rule. Now, question number 3 is compass needle is made up of a magnet containing North Pole and South Pole. So, and the North Pole of a compass needle point north on the Earth. So which row in the table describe a magnetic field of the Earth? So our Earth is behaving like a magnet. So our Earth has one North Pole and one South Pole. And the North Pole is originating the magnetic field of line and they are entering into the South Pole. So mean the direction of field of line is north to south. So here, so if the compass is showing the North Pole, so the type of magnet pole near to the Earth geographic North Pole, it will be south. So the direction of a field of line force, according to the magnetic principle, this is moving from north to south in direction. So our correct option is here C. The next question, a ball is inflated with air. In which environment will the air inside the ball have the highest pressure? Now, if you want to see the pressure relationship with the temperature, so temperature is directly proportional to the kinetic energy of the gas molecule. If you're increasing the temperature, the kinetic energy of the gas molecule will increase, so they will collide with each other and collide with the wall of the ball and apply more pressure. So that's why the kinetic energy is directly proportional to the pressure. So indirectly, we can say if there's a higher temperature, there will be higher pressure. So we can see which option where is the highest temperature. So you can see the option D, outside a warm day, that's 21 degrees Celsius. That is the highest temperature as compared to the other option. So D is our correct option here. The question number 5 is related with electricity. 1.5 volt cell transfer 18 millicoulomb of charge in a circuit. What is the amount of energy transferred by the cell? Use the data sheet. So you can see we can solve this question by knowing the formula. The energy transfer in a circuit is equal to the total charge multiplied into the volt difference or voltage. So here, the total charge is given there. That is the 18 millicoulomb multiplied into the voltage, and that voltage is 1.5. If you're going to multiply this figure, and our answer is 27 millijoule of value. Now, sometimes examiner asking question, this similar type of question, but the unit is different, then you have to go for correct unit. But here, examiner asking the unit is in millijoule, so that's why directly this value you can use it. So our correct option is here, C. In a question number 6, a student does 27 step-ups onto the wall. The total work done by the student is 3,000 joules. The time taken is 24 seconds. So to calculate the power of the student and use an equation, the power is equal to the work done divided by time. So here, the work done is the 3,000 joule is given in the question, divided by the total time is 24 seconds. So our final value will be 125 volt is of the work. So that's B is our correct answer here. Now, next question is about a student measure the mass and volume of 4 blocks. The graph show their results. So one side along y-axis, there are masses given there. Along x-axis, there is a volume. Which 2 blocks have the same density? If you want to measure the density, the formula is a mass over volume. So you need to check about the mass over volume of the different point. So which 2 points they have the same answer. For example, if you're going to check this value of a point Q, so in a point Q, you can see along x-axis, so this value is a 4 centimeter cube, while along y-axis, the Q has a 2 centimeter and 2 gram. So 2 gram of mass over 4 centimeter cube of volume. So answer is 0.5. In the same way, if you want to check that the value of the S point, so in an S point along x-axis, there's an 8. There's an 8 centimeter cube of the volume. Along y-axis, the 4 mass, the 4 over 8, answer is coming 0.5. So these 2 points are having same answer. So that's why they have same density here. So our correct option will be C here. The planet X and the Z are same size. So there are the 2 planets who have the same size. The gravitational field strength on the planet X is 12 Newton per kg. Now, planet X has a mass is 1 into 10 raised to the power 25 gram, 25 kilogram, and the planet Z has the mass of 4 into 10 raised to the power 25 kilogram. So what is the difference of planet X and planet Z is 4 times. So you can say that planet Z is 4 times as compared to the planet X. So what is the gravitational field strength on the planet Z? So this data, the gravitational field is directly proportional to the masses or product of the masses of object. So, and inversely proportional to the square of distance between them. So we're going to use this formula of the gravity. So the gravitational field is directly proportional to the product of masses of object. So you can see that the planet, that if there is a planet X, is a 4 times greater so than to the planet Z. So here I'm gonna change this value. So that's gonna be planet Z. If there is the planet Z, that's our Z value. if there's a planet Z, is a 4 times greater as compared to the planet X. So we can do what? We're going to multiply that the planet X value is a 12 Newton per kg, multiply into the 4. So this will give us a 48 Newton per kg is a planet Z gravity. So our correct answer will be here, the D, 48 Newton per kg. The gravity will be on planet Z. And here there's a formula. We are using the gravity is directly proportional to the masses of, or you can say to the product of. So the product of masses of the object. So if there is a two object, they have a greater masses, that will be greater the gravity. In a question number 9 here, a toy train move around a circle of a track. The speed of the toy train is 2 centimeters per second. What is the velocity of the toy train changing? So what is the velocity of the toy train is changing? So it's basically, we studied the velocity is a vector quantity. So here, the constant, the speed is, velocity is the same, but the direction is changing. So if by changing the direction, the velocity will be in a changing mode. Why? Because this car is moving in a circular path, and in the circular path, in every movement, the train is changing its direction. So that's why by changing direction, its velocity is changing. So D is our correct option here. The toy train the toy train is changing direction. We're going to move to the next question here. The question number 10, the child uses a force of 10 Newton at an angle of 60 degree to push the toy car. This is a scale diagram for this force. So we can see that scale diagram is showing 1 Newton is equal to 1 centimeter. So that's our scale is given there in the question. So what is the horizontal component of force pushing the toy car using the scale diagram? So if you want to see that, the scale diagram, for example, along y-axis, you can see toward the north, there is the 10 centimeter of the distance is being traveled. So we need to do that, and we need to find about the horizontal distance. To find the horizontal distance, we will draw an arrow from the final point of the 60 degree toward the north. So we can drop this arrow down. So for example, if it is moving and touching to this point here, so that's the final point. Now we can measure along x-axis the distance. For example, that's the starting point, and this is going to be a final distance here. The point where it will touch, so we need to measure about this distance. This is 5 centimeters. So you can measure this distance by your scale. That is equal to the 5 centimeter or 6 centimeter. So whatever the distance is coming, this 5 centimeter is equal to the 5 Newton according to the given scale, and that will be your correct option. So we're going to proceed to the option here. So if there is a 5 Newton, so 5 centimeter is equal to the 5 Newton. So our B is our correct option here. So we have completed the section A. We are proceeding to the section B here. So the question number 11 describes the difference between the specific heat capacity and the specific latent heat. So you need to differentiate between the specific heat capacity and a specific latent heat. So specific heat capacity is the energy needed to raise the temperature of 1 kg of the substance by 1 degree Celsius or 1 Kelvin. So while the specific latent heat capacity or specific latent heat is the energy needed to change the physical state of 1 kg of the substance without changing its temperature. For example, if we say the latent heat of fusion of a solid, so how much energy is needed to melt the solid into a liquid form? So that's why the specific latent heat capacity is latent heats are different for the different solid. So for example, the ice melt at the 1 degree Celsius. So how much energy is needed to melting the ice from solid to the liquid form? That will be specific latent heat of ice. So we're going to move to the next question. A small heater is used to increase the temperature of a different liquid. So the graph show how the temperature rise changes due to the varying specific heat capacity of this liquid. So you can see along x-axis, there's a specific heat capacity, while along y-axis, there is the temperature rise. So if there's the specific heat capacity is increasing, so the temperature is also high value. And the different substance which has low specific heat capacity, there's a low increase of temperature. So sorry, that's going to be the substance which has a high specific heat capacity, they have the high increase. There is a high rise of temperature for them. So that's our overall trend in the graph. So we're going to see that the question here, using the graph, describe the relationship between the temperature rise and the specific heat capacity. So you can see as the specific heat capacity increases, the temperature decreases. So that's why the things which has the high specific heat capacity, so there is they can resist to increase of more temperature. So that's why their temperature stays same, or there is a high resistance to increase of their temperature. So overall, you can describe the graph as the specific heat capacity is increasing, the temperature is decreasing. So that's our one answer. We're going to proceed to the next question. A liquid has a specific heat capacity of 1600 joule per kg. That's at Celsius. So use the graph to estimate the temperature rise of the liquid. Now, temperature rise is in our marking scheme is given to the figure like 36 to the 39. That will be our correct option. So now here they started the graph after the 1600 of a specific heat capacity. So here to get the idea about the plotting the graph, so we can get idea. For example, if there is a value, so here we can see the specific heat capacity value is of a 16. So first we will draw an arrow from the 16. So two small boxes along x-axis, that is equal to, there's a 100. So we can proceed ahead. So if this value is coming here, that's our 16. So at a point, the 16. Let's suppose that's the value. This is going to be of 16. Let me go for a more precise value here. So that's our value. I suppose. Now this is going to be, now here, if I'm going to draw a line here, it's supposed to be a more precise. So if you draw a line by the scale, so that will be more precise. Now, the point where they are crossing or intersecting with each other, we can see that this value along the y-axis value, for example, that's the point. If I'm more accurate or more precise, like this line is more precise, so you can see this point is coming here. So this value will be around near to me, and you can see this according to me, this value is 27 is coming here. So that value is 27 Celsius for me. So in this way, you can measure this value by plotting this graph, and the examiner could not measure this value, so we are going to considering this value. So your answer is supposed to be in between 36 to the 39 Celsius temperature. State one assumptions you made when you're answering the question number B2. So why not the examiner give us this value, and why not this value come in measurement? So we can make an assumptions the power of the heater is the same, or I can say the time the heater is switched on is the same. So at the same time, or you can say there is no change of the state has occurred. So that's why they did not measure the specific heat capacity at that temperature. So you can put your answer any one assumptions, so that will be correct. A student calculated the specific heat capacity of water. the student does one experiment and get this result. For example, these results are given there about the specific heat capacity. So that's our the student value is 4,250 joule per kg Celsius. And the textbook value, standard value is 4,200 joule per kg Celsius. Now complete the sentence below to use the word. So what is the difference between student value and the textbook value? So there's not much difference. You can see the 50 is the value, 50 joule per kg is the difference. So you can say the accuracy. So accuracy refers to the closeness of measured value to a standard value or a non-value. So that is called accuracy. To answer this question, we need to see that the further different the definition. For example, if you define about precision or precise value, so closeness of two or more measurement. For example, if the one experimenter who measure 2 value or 10 values, and these 10 values, how much they are closer to each other. If there's a more close these points, these are more precise. If these points are more scattered away, so these points are less precise. So their precision will decrease. The next is reliable. How many times the experiment is repeated with a similar result, that is the reliable. For example, if the examiner has repeated this experiment 5 times and the result comes same, so that means the reliability of this experiment will increase. Next is repeatable. If there's an original experiment or investigation is repeated by using same method or same equipment with the same results. So that is mean this experiment is repeatable. Now, systematic is what the measurement of experiment is influenced by the given environment or whatever the apparatus we are using, it's affecting on our measurement. Sometimes you're using systematic error. So if there's the environment is affecting and our results are coming different, that is called systematic error. So the result of student is near to the standard value. So that's why we can use here the word accurate. So in a further exam, examiner may give you any of a definition from here. So you should know that the following definition of these different points. So we have done that. We're going to move to the next question here. And this question is related to the electricity or circuit diagram. A teacher built a circuit shown in the diagram. Now, this circuit, you can see the cell here. That's a source of current. We applied the ampere in ammeter. That's in series in circuit, while 2 ohm and 8 ohms are the two resistance. These are in series. What about the voltmeter is applied in parallel to the 8 ohm resistance? So that's our complete circuit. Now, first question about the circuit is give the total resistance of the circuit. So what is the total resistance of the circuit? So if you want to measure about the total resistance, and these resistance are in series in a circuit, so we can use this in the formula. The total resistance is equal to the R1 plus R2 plus so many. So in this way, you can see the 2 ohm plus 8 ohm directly, we can add the total resistance will be 10 ohm. So here, now the voltmeter read for the volt difference. So 4 voltage of current, 4 voltage here across the circuit. Calculate the ammeter reading. So if you want to measure the current, so the formula for the current is equal to the potential difference divided by the resistance. So that's the current value. What about the formula? What we have driven this, V is equal to IR. And here we can modify this formula. So this will become the current is equal to the potential difference divided by resistance. So potential difference is 4 divided by we got the resistance. Across that, you can see the voltmeter is applied in a parallel to across the resistance 8. So we're going to divide 4 over 8. So our answer is 0.5 ampere of current. So here, the correct answer will be 0.5 ampere. So we're going to proceed with this answer. Calculate the potential difference across the cell. So if you want to see in the calculated potential difference, so the total formula for potential difference is voltage or potential difference is equal to IR, I is our current, and R is resistance. So we can see that the I current we calculated 0.5 ampere multiply the total resistance in this circuit, that is the 10 ohm. So that is equal to 5 volt. So total volt across this circuit will be 5 volt here. So here we got answer. We are going to proceed to the next question here. The children often make the model with the clay. Now, clay and the spring behave differently because the spring structure is a different, that's a metallic structure. What about the clay is not a metallic structure? So draw the 3 lines to match the material to their property. So these properties are given, for example, elastic. So elastic is what? That's the ability to its original size, to gain it, to return to its original size and shape when the force is removed. For example, if you apply the pressure on the spring and the spring will stretch, and if you release the pressure, the spring will regain its normal shape. But if you apply the same force on the clay won't get its normal shape. So that's why this is the property of spring. What about the Hooke's law? If you apply the pressure is directly proportional to the length extended. So force is directly proportional to the extension of length. That's the Hooke's law. Now, within the elastic limit, the spring is obeying this law. What about the clay is not obeying this law? What about the plastic behavior, the mold into a different shape and size? What about the spring cannot be molded into a different shape and size? What about the clay has a property, it can be molded into a different shape and size here. So the correct option, if you're gonna plot that, so that value will be R here. So clay is following a plastic behavior here. So that's your arrow should move, proceed toward the clay. What about the spring is following a behavior of elasticity, that's elastic, and the spring is following the behavior of the Hooke's law. So within the elastic limit, the spring is following Hooke's law here. So that will be our correct answer here. I'm going to proceed to the next question. Now, the 2 children are squishing clay on the desk. And the child A say only one force is needed to the squish clay. Child B say there are 3 forces acting on the clay, and when it's squished so the clay. Use an idea about the forces, explain why the child B is correct, and use the free body force diagram to help to explain this answer. If you're going to see that the free body diagram here, and for drawing of a free body diagram, so in this way we can see that, for example, that's let's suppose this is clay, and in this clay, on this free body, the forces are acting on the object downward in direction. For example, one force which is acting downward in direction, that's one is the gravitational force. And second type of the force, which is acting downward in direction, this is the applied force, what the force the boy applied on the ball. So this will be, that's going to be applied force. What about the upward force by the table surface? So there will be one force which is going to apply, that's a normal force. So which going to apply upward in direction, that is the surface of table. So overall resultant force will be what? That is equal to 0. So the resultant force will be 0. Why? Because the clay will stay on its position. It will not move. So here we can explain this point here. So number 1, if there was a single force, there would be a resultant force, which caused the acceleration but the clay held in its position due to the normal force of the surface. So the clay is not moving, or there's no acceleration in the clay. So clay stay on its position. So that's why more than one force is being applied on the clay. So we can explain this answer. So one force is downward weight of the clay by pulling the gravity. Second force is also a downward by push of the hand. And the third is a normal force of surface of the table is being applied upward in direction. So in this way, the resultant force will be 0 here. So we can see one force is downward of gravity, second force is applied force of by the hand, and these two forces are cancelled by upward force of a surface of the table. So overall, the resultant force will be 0. So in this way, you can draw and you can also explain your answer. We're going to move to the next question here. A student investigates if the length of the resistance wire has linear or non-linear behavior. So the length of the resistance wire has a linear behavior or non-linear behavior. So they use the circuit diagram to explain that. Now the circuit we are having, there is a key in the circuit. We have a variable resistance, and ammeter is applied along the series. What about resistance is in series, and voltmeter is applied along, that's our parallel mode. So here we can check that this value. So we got the result here. This is their method to turn on the power. First, they turn on the power and measure the potential difference and current first, and then they move the slider on variable resistor, and they repeat the measurement of the potential difference and the current. So here, this is their value, or this is their method, how they are doing that, and they got these different values here. So we can see these following different values, they correct. Now we're gonna move to the students say, I think my results are linear. So evaluate the results, student graph and conclusion, and suggest how their method could be improved. So we need to give a graph analysis, number one, and then we need to conclude that, number two, and then we need to write the improvement method here. So if you see that the graph analysis, so you can see in the graph along x-axis, this is given, that's a potential difference, that's along x-axis. What about along y-axis? There's a current is given there. So you can see in the graph, the values are given, and these values are coming in not a straight line. So when we are going to plot this value, for example, this line, the graph line is not coinciding with this point. What about this graph line is coinciding? You can see this is the linear. So the straight line is proceeding in this way. For example, if I'm going to plot the straight line here, so the line of best fit, this is going to proceed. So that's the maximum point that can proceed here. After this point, this is going to be curved line. So for example, when this point will touch to that one, and that point will touch to this point, this is going to be a curved line. What about the line which is drawn here? That is not correct. Why? Because it is not the coinciding with the different floating point. So that's number two. This is overall the description of the graph. So until the point, now until the point, you can see this point here, until the 2 ampere of current, this is linear, and further, this will become curved. So this is the given results. So we can suggest that if there is an increase of temperature, for example, if the temperature is increasing, so for example, if there's a volt difference is increasing, so the current is also increasing. If there's an increase of current, so the temperature is also increasing. And if the temperature is increasing, so the resistance is also increasing. And if there's a resistance is increasing, so this is affecting the flow of current. So in this way, we can have this relationship. Voltage is equal to IR So that's our value. Now, if you want to see that the current, so the current value is equal to voltage over the resistance. So we can see if the resistance is increasing, so the current will decrease. So that's the reason behind. So in this way, for example, if you're increasing the potential difference, so the potential difference is directly proportional to the resistance. So for example, if you're increasing the potential difference, resistance is increasing. Now, if the resistance is increasing, so the current is decreasing. And if the current is decreasing, so that's why you can see by increasing of the potential difference, this is going to be curved down. So that's why, number one, the line is not correct. It's not following the all different point. It's not linear. It's a linear until the point 2. And what is the suggestion for that? We should use the wire at low temperature, or we should cool down the wire. So in this way, that will give us the linear behavior. That's number one. Number two, we can say we can use the wire at the low voltage. For example, until the voltage of 1.5, if you will use, the result will come linear, and this will obey the law. But if you will go above to the 1.5, so this will not obey the law, and the result will be non-linear. So we can explain this answer here, so we can see how we can explain this answer. So I'm proceeding to the question here. Now here, there's a question. You need to first describe. So in the description, the line is incorrect. The line is a wrong place. So why? Because it's not coinciding of an all plotted point. So line does not show a correct trend. The line and the plots are not mating. So that's your description. The number two, you need to give an explanation about that or conclusions. So the line is only correct up to the point 1.5 voltage, or you can say 2 ampere. This is giving a linear behavior. And after that, the line is non-linear. The line should be a non-linear, or it should be in a curved line. So it means that the resistance is only constant up to 2 ampere of current. So what's the idea you can explain? The idea is that the wire does not obey the Ohm's law after the 2 ampere. So the wire may have increase of temperature. So if there's an increase of temperature, this will directly affect the current flow. So in this way, this will not obey the Ohm's law after the 2 ampere or after 1.5 voltage. Now, how we can improve this experiment? So we can improve this experiment by switch off the current between reading and cool down the wire by allowing an extra time. Or we can use a smaller current value, mean up to the 2 ampere of current. This will give a linear behavior, and this will obey the Ohm's law. Or if you're increasing the number of the reading with a smaller interval, so we can also improve our results. So 1 or 2 improvement, you can put that in your answer. So that's our correct answer here. So we have done that, and that's a long question. So you need to first describe of your graph, and second, you need to explain of your results, and then you can suggest the corrections point here. So I'm proceeding to the next question. An athlete ran a 100-meter sprint. So this is the distance time graph here. So distance time graph for the athletes moving. So you can see it's moving at from the 0 to the 2 along x-axis 2 seconds, and after this 2 seconds to the 4, this is acceleration. It's increasing, and further, if you're going to proceed from a 4 point to the onward, so the same distance is moving with the same interval of time. So there is a constant velocity. So we're going to proceed to the first question here. Describe the athlete's motion in the part A and in the part C. So the part A, you can see, so there is an increase. You can see this line is further. There's a gradient is changing. So this means there's an acceleration due to increase of velocity. So after A to the B, that's the transformation. So there is an acceleration, or speed is increasing. And in this way, in the C point, you can see the distance is being moved with the equal interval of time. So we can say there's a constant velocity at C. Now, the next question is about after the first 4 seconds, the athlete's speed is 11.5 meter per second. They traveled a distance of 32 meters. And they calculate their acceleration during first 4 seconds. If you want to calculate the acceleration, we can use this formula. The 2as is equal to the final velocity square minus initial velocity square. So you can see the initial velocity at 0 second is 0, while the final velocity is given in the question, that is 11.5 meter per second. So in this way, we can modify this formula according to the requirement because we need the acceleration here. 2as is multiplying, other side it will divide. So that will be our given formula. So we're going to calculate this final value. So now here you can see the acceleration. So that's acceleration is equal to the 11.52 square. So this is going to be 11.5. So more precisely, you can take this value here, only 11.5 here. So let me check that correct this value. So we can take it more precisely. This is 11.5 value. So you can check this value here. Yep. So that's a square value. Now here, so this acceleration is equal to the 11.5 square minus 0 square divided by 2 is the value in a formula. Multiplying 32 is the distance. So we can get this value 132.25 divided by 64. Our answer will become 2.066. So in average, that value will become after rounding in figure. So this will become 2.07 meter per second square. So now here that will become 2.1. That will be our final answer here. So you can use your calculator to calculate your value up to the correct 2 significant figure here. So our final answer will be 2.1. That's a meter per second square. We're going to proceed to the next question here. And this next question, a teacher teaches their class about the momentum. So we need to define the term momentum. So momentum is defined as a quantity of a motion of a moving body, which measured as a product of velocity and its mass. So for example, if an object is moving with a certain velocity, so what is the mass of that object multiplied to its velocity? That is equal to its momentum. So you can also put your answer in a form of equation here. The momentum is equal to the mass multiply its velocity. Now, question 2, define the principle of conservation of momentum. So total momentum is a constant, is an isolated system. For example, if there's a closed system and there's no any external influence on this system, for example, if the gas is closed inside of a container and there's no external influence on this gas, so the total collision of these gas particles with each other, with the wall of the container, that will be equal. And there's no change of that momentum. So that's why we can say the momentum before of collision is equal to the momentum after the collision in an isolated system. So that's the law principle of conservation of momentum. We're going to proceed to the next question here. In an experiment, show figure 16.1, the teacher uses the pellet gun to shoot an apple. Now, velocity of this pellet is 150 meter per second. This is our initial velocity. The mass of the pellet is 7 grams here. So first we will calculate the momentum here. So calculate the momentum of the pellet before it hit to the apple. So before it is heading to the apple, we're going to calculate its momentum. So we can see this, the mass is equal to, first we need to convert this, the 7 grams of mass of the pellet into the kg. So 7 divided by 1000 gram, that is equal to 0.007 kg. So we are converting this value. Why? Because we should have the same unit. And you can see in the answer, there's a required unit is kg. So that's why the given gram, we need to convert it into kg by dividing 1,000. Second is the momentum. So momentum is equal to the mass multiply the velocity. Now mass is 0.007 kg multiply 150 meter per second, and the total momentum will be 1.05 kg meter per second. So that will be 1.05. You can also average into a significant figure of this value further, 1.1, so that you can also make it an average or round in figure 1.1. We're going to proceed to the next question here, and a teacher repeat the experiment with a different pellet shown there. Now, momentum of the pellet is 1.1 kilogram meter per second. That's our initial momentum. So we calculate it. For example, this is a given there. So now, before the collision, this momentum is 1.1 kilogram meter per second. And obviously, after the collision in an isolated system, the total momentum will stay same. Here, the pellet become stuck in an apple and they move off the wall together. So the pellet stuck inside of the apple and they both move away from the wall, out of the wall together. So it means the weight of the pellet plus weight of the apple, we will take it together. So for calculation of its momentum. So you can see the weight of the pellet is 0.011 kg, weight of the apple is 0.089 kg. So first we need to add that's the total momentum, total mass. So calculate the velocity of the pellet and apple after the collisions. So after the collision, so one general rule about law of conservation of the momentum is that the momentum before the collision is equal to the momentum after the collision. So you can see the momentum before the collision is 1.1 kg meter per second, and after the collision, there will be same value. Now here, for calculation of the velocity, we need to calculate the momentum after the collision divided by the total mass. Now, momentum after the collision will be same, 1.1 kilogram meter per second, while the total weight will be, if you're going to add these total weight of a pellet plus apple, so the value is coming 0.1 kg. Now, if you divide the 0.1 kg value to the total momentum, so our answer is coming with the velocity. So the kg sign will cross with a kg. For example, if we cross this value of one of this kg value, and that kg unit will cross, and our final answer will stay, and that will be our point. That's going to be 11 meter per second. So this will be our final velocity of apple. Here we got our answer. We're going to proceed to the next question here. And next question is about the magnet. The diagram show a wire placed in a magnet. So if we take a wire with the current and we place it inside of the magnet, and you can see there's a circuit is given there. And in this circuit, there's a source of current, battery, and we have a switch S, and we have a ampere ammeter is showing there in a series in a circuit. And in this series in a circuit, you can see the magnet. We place these two magnets, and between these two magnets, this wire is moving. Now, that's whole apparatus is placed in on the surface of the one. We have a weight scale, so a weight measuring scale. So we want to see this. What type of question are here? The electronic balance is used to work out the force acting on the wire. So we're using this electronic balance to measure what is the forces acting on the wire. So when the S switch is open and the circuit will get closed and the current start flowing through the circuit, so the electronic balance reading is 0. So explain why. So why there's when the circuit is open, when the circuit is open, so there's no current is flowing through the circuit. When the circuit is, when the switch is closed, so the current will be flowing through the circuit. So at the time when the circuit is, when the switch is open, so it means that this switch is open right now in this condition. So you can see circuit is not closed. So in this way, the current is not flowing. So if there's a current is not flowing, so you can see if there's no current in the wire, So no value of applied force. So the value of applied force will be 0 on the wire here. So that's our one answer. So we're going to proceed to the next question here. When the switch S is closed, so electronic balance has a quantity reading to the 0.3 gram. So explain why the balance show the reading to the switch S is closed. So for example, when the switch S is closed, so the circuit start flowing the current through that. If the current will flow between the magnetic field, so this wire, which is having this flowing charges, these flowing charges will generate their own magnetic field. So the magnetic field of the wire will affect to the magnetic field of field lines of the magnet. And that's why the field line of the magnet or influx of the magnet will apply force on the wire. And this force will increase the weight on the weight balance. So that's why we can explain this whole phenomena here. So current in the wire causes magnetic field around the wire. This magnetic field interact with the field around the magnet. So when it will interact with the field around the magnet, so the force on the wire is acting downward in directions. So we can also find by a right-hand rule with this. So this force is acting the downward in direction. So this force is measured by the weight balance, and this is giving the weight 0.3 the gram. Now, the next question is, state the reading on the balance if the polarity of the battery is reversed. For example, this battery, what we are connecting the positive end and the negative end. So negative, we connect to the positive, positive, we connect to the negative. So direction of the current will change. When the direction of the current will change, so the applied force will also change. So that's why we can also find by this by the method, by the right-hand rule method, by the magnet. So here, so we can give our answer here. So if there's the polarity of the battery will change, the direction of the current flowing will reverse. So this way, the force will reverse in direction. So first it was positive 0.3 gram. Now it will become negative 0.3 gram. Now, polarity of the battery is unchanged from the question. What's the value is given there in B1 answer. So state the reading on the balance of the pole of magnet or reverse. So let's suppose, for example, if you're going to change the pole of the magnet, for example, north pole is replaced by south and south pole is replaced by north. So we're going to change the direction. So in this way, the line of force direction or magnetic influx line of force will change. So when the direction of a line of force, for example, we studied the direction is moving from north to south. So if you're changing these pole, and that's in this way, the line of force direction will change. So the same result will happen. So the direction of effect of force of magnetic influx will also change. And that's why 0.3 gram. So this value will change into minus in opposite in direction minus 0.3 gram. So that's our correct answer here. We're going to proceed to the next question. This experiment is repeated, and when the switch S is closed, the force on the wire is 0.004 Newton. Now, ammeter read 0.8 ampere of the value current, while the length of the wire is given 0.05 meter. You need to calculate the magnetic flux density around the wire. So the magnetic flux means the total number of the magnetic field line are passing to the wire. So that's our magnetic influx density. So if you're going to calculate the flux density or magnetic field line density, so that is equal to what the force applied on the wire divided by the current multiplied into the length of the wire. So in this way, the force applied on the wire, that's equal to 0.004 and divided by the current, that's 0.8 multiply 0.05. And in this way, if you're going to calculate this value, and our answer is coming 0.1 Tesla T. So T for Tesla, that's a unit of the magnetic flux density. So that's why that's a more famous branded car, that's a Tesla. So they are using the electric, the source of electric as a source of energy. So this electric current is passing to the magnetic field, and this is supplying overall force. So in this way, the electric force is converting into a magnetic field line, and this magnetic field line is converting into the mechanical energy, and in this way, the car is moving. So that's why they use this unit of flux density, the Tesla, with that prime. So here we have a flux density is 0.1 Tesla. That is our answer here. We're going to proceed to the next question. Our student investigated if the current in the wire changes, the force on the wire also changing. So answer the questions to describe how the student can do this investigation. So for example, if we are measuring the current here. So now in this way, whatever the things what we are measuring or you're investigating, that should stay very. So here the student vary the current by using variable resistor. Or you can use a different, the voltage of the battery or different voltage of the cell. So then in this way, your current will be vary here. Now, what does the student control? So whatever the investigations, if you're doing what the things you're measuring in your investigation, that will stay vary. What about the other value which can directly affect your results that will stay constant? For example, flux density is directly proportional to the force, and the flux density is inversely proportional to the current and the length. So that's why the length and the flux density should stay same. What about the current is varying because you're investigating on current. So in this way, the length of wire and strength of magnetic field should stay constant or in the control value. What about the current should be in a change? So this answer will be our correct. So we're going to proceed to the concluding mode. Here I have explained, I try my best to explain with a reference of different formula. If you find any problems, so you can also put your question in a comment box. Hopefully it will be helpful for you. Thank you. Thank you very much.